What's going on, everybody? Boris here at your College Design Studio, bringing you part 4 of this run-along series where we try to learn Java together. I've got some really exciting stuff planned for you in this episode. What was at first a very simple program took me to places I didn't even know about. What you're seeing right now is the program we'll write in NetBeans in just a second, but for now I want to show you something I discovered by accident: how to compile code in Notepad++. So far we've been using NetBeans, which is great. It's a fantastic IDE with a built-in compiler and everything. But what if we wanted to play around on Notepad++ and compile simple programs in that way? If you have the basic Notepad++ installed, try pressing F6. Nothing should happen. That's because you need a plugin called npp exec. And the way we get it is we go to Plugins, Plugin Manager, Show Plugin Manager. Now, as you can see, I already have npp exec installed, and the description says that with this plugin, you can execute your commands or save scripts without leaving Notepad++. Go to Available, go all the way down, and it should be between npp crypt and npp jump list. Install it, and now when you press F6, a little dialog box should pop open. These commands will not be entered in already. We have to do that manually. I know it's kind of small, the script is kind of small, so let's copy this. Let's press cancel, and let's paste them over here. I hate to do this, ruin this beautiful program. Okay, we need to set our environmental variable, the location where our Java development kit is. This is where all our libraries are at, because if we try to do this now, for one, it would not recognize any of this. Even though Notepad++ recognizes it, the compiler will not know where to pull this information from. Also, we're importing class scanner. It doesn't know where to import it from. It needs to know where the Java development kit is, where all the libraries are contained, in order to do this. Next, we need to change directory, CD. And then we need to declare exactly where the location of our document is. For me, it's in Documents, and a folder called Video Scripts. Next, we need to enter this exactly as we see it. Parentheses, $, system.java or sys.java /home bin javac. That's telling our compiler to compile this code here and then execute this program. This is the file name, which is going to be interest.java and interest. So let's try this. Let's delete this. And let's try to run it by pressing F6, clicking OK. And this is what our program is going to do. Again, the script is kind of small. We can see much better in NetBeans, and we'll switch over to that development environment here in a second. But to demonstrate the end result, we type in an amount, an initial investment amount. Then we enter a rate, and as you can see, we're already using decimals. So here we're using double variables. So say 0.05, and it calculates the amount for each year for 10 years, given an initial investment amount and interest rate. I've gone ahead and switched over to NetBeans now. Go ahead and open a new project and call it interest. And on the new line, we're going to do package, interest, our import declaration, java.util.scanner. In the example program that I was looking at, it basically had you declare what the variables were in the beginning. So instead of having the user enter the amount, it would set the amount to 1000 and it would set the rate to 0.05. That doesn't seem very useful. Import class scanner for user input. Pretty basic stuff. But basically what the program did is it had fixed values, and it calculated the interest amount for 10 years for $1,000 at 5%. Again, that's not very useful to somebody that might have invested a different amount at a different rate. So what I went ahead and did was took some time to figure out how to receive user input for a value, and now we can have decimals and then input that value and calculate the interest rate for anything. So it's a very flexible program. I'm kind of happy with myself because I'm not sure if it was going to work or if my knowledge was good enough and sufficient enough to accomplish this, but it worked out. Public class interest. our opening and closing brackets. Get those good habits going. Let's declare our main class. Public static void main. String args. Opening and closing bracket. Now we do scanner input equals new scanner system.in. So far we have not encountered anything new, but now we do double, if I can spell it right. We're initializing and declaring our variables now, but instead of integers, we're doing double so that we can take advantage of decimal points and have more precision in our calculations and our outputs. So this is going to be amount at the end of each year. Double principal, that's going to be the initial amount or initial deposit before interest. Double rate. To give you an idea of what the program I was looking at, the example program did was they did this. Equals 1000 equals 0.05. To me, that's not very useful. It doesn't give the user any flexibility or any choice, as we talked about previously, so I erased that and try to wrap my head around how I can solve the problem before me, of making the program more flexible so that the user can enter any amount at any rate and still receive the calculations accurately for 10 years. Everything is going to be in the same in our main class, and we're going to do system.out.println on a new line. Enter the initial amount in dollars. Let's not forget our semicolon. And here's where it gets interesting. Here's where I made a mistake the first time around, because I was going off what I know. Principal equals input dot next, and I think you know what's coming. I typed in int, and what it needs to happen, because this is telling it input dot next integer, and it's looking for an integer value. So what happened was, when the user typed in, for example, 0.05 or 0.05 for an interest rate, although here we're dealing with dollars, when it did that for the interest rate, it freaked out. It gave me errors, compile time errors. The program compiled fine, but when I was trying to execute it, that's when it gave me an error. When I typed in a decimal value instead of an integer value, that's when it failed. So what we need to do is delete int and type in double, as opposed to integer dot next int. Okay. System.out.println. We want to skip a line, I believe. No, let's go ahead and do enter the rate. And we want to give the user, we want this to be a user-friendly program, so we want to tell them or give them an example of what they should type in. 0.05. Like this. Our semicolon. And then we want to do rate equals input dot next double, like this. Okay. System.out.printf. Here's where we have some of the weird placeholders for strings. And we do comma year, and we do amount on deposit. This is going to be just the first line in a mock table, if you will, where we display all the data to our users. Here's where we do our calculations. We need to calculate the amount for 10 years, and we're going to do a for statement. We're going to take a look at what that is at the end of after we finish our program. Year equals 1, so we're declaring our variable year here, so it's going to be a local variable, and we're setting it equal to 1, and then we're doing year less than or equals to 10. So every time this execute is going to check if the statement is true, and we want it to be less than or equal to 10. So if it's 11, it will return false, and we want to increment it. Remember in the previous video in our episode 3, we had pre and post increments. This is a post increment because each time this line executes, it will add 1 to their, not 100 or 10. There you go. It's going to add 1 to the amount of years. And then opening and closing brackets here. Let's do, we want to calculate new amount for the specified year. Amount equals principal times math power 1.0 plus rate year. We're basically adding 1 to the rate in the given year. And in the for statement, think of it like this. For year 1, when years are less than 10, calculate this. That's all a for statement does. Remember pseudocode that we took a look at in episode 3. We can talk it out and see what's going on ahead of time. System.out.printf percent for the 20.2f and year amount. So it's going to input the year and then the amount. I believe that's it. We're going to end the for statement, end our main class, and end our class interest. Let's check for errors. No errors. Everything seems to be in order, and let's see how this program executes. Let's compile it and run it. Bingo! Works perfectly well. Remember, we typed in println, so it's going to put the cursor on a new line down here below. And let's do $1,000 working so far. This is where it freaked out for me when I had next int instead of next double. I typed in 0.05 and it lost its mind. Now it should be working. Build successful, total time 24 seconds. And the amounts, I don't believe they're accurate. Something's off here. Let's find out what it is. Let's close this. We have %4D. We're missing a percent here. I believe that's what's going on. Let's try this again. Enter the amount, 1,000, 0.05. Success. Yes, we want it to have, we're missing that percent. The program still compiled with no errors, but the output was completely different. But these are the correct amounts that I have here before me, $1,628.89. And you can check for yourself. Now let's take a look at what some of these strange formatting things are. For example, the %4D, 20.2f, and all of that. Let's go through it in detail. We've jumped back to Notepad++ so we can briefly discuss some theory. The expression that we saw in our program, math.pow, does indeed stand for math power, because it calculates the value of x raised to the yth power. And the expression is as such: math, period, POW, and in parentheses, x, comma, y are two variables. The calculation is y equals p in parentheses 1 plus r to the power of n. If this equation looks familiar, it should, because that's the basic compound interest formula. Our method in this case receives two double arguments and returns a double value. Y in this case equals the amount. P equals the principal, the initial amount invested, R the rate, and N the number of periods, which in our case is in increments of years. The year is output in a field width of 4 characters, like we're used to on most formats, specified by %4D, and you might have already guessed that 4 specifies the width, the number of characters that are allowed. The amount is output as a floating point number with the format specified %20.2f. Now the comma is a formatting flag, and it indicates that the floating point value should be output with a 1000 separator in a comma, such as 1000 or 1,000, and not just 1,100. There can be some problems associated with using floating point numbers, and most manuals recommend not using floating point numbers when doing precise monetary calculations. And this is why. Say for example we have 2 numbers stored in our computer, in our memory, 10.234 and 12.673. They will be displayed as such, 10.23 and 12.67. You can already guess where this is going. The addition result of these 2 numbers is 22.9 or 22.90. However, the program will display this 22.91 because it's going to add these and say that the result is actually, or internally it's going to know that the result is 22.907, and it's going to round that up to 22.91, which is the actual amount. And you can see how, if we're dealing with, say for example this was not just a regular number, $22, but was a multiple of a million. So this decimal point actually signifies $22,910,000, and that one, when it disappears, there goes your $10,000. So precision is important in calculations, especially those involving money. For the sake of tradition, I've jumped back into NetBeans so we can review our program line by line. In the first line, we're referencing our package. Capitalization matters, and we have the I in lowercase. In the next line, we're importing java.util.scanner so we can receive user input. We're declaring our class as public, and we're calling it interest with a capital I, which references this file here. We're declaring our main class public static void main string args. Then we're initializing our scanner input. We're initializing our variables and we're naming them. And instead of restricting our program to a specific amount like $1,000 and a specific rate like 5%, we're leaving these as they are, so that down here we can do system.out.println and prompt the user for the initial amount, and then prompt them again for a rate. And here, instead of next integer, we're doing next double. Here we're outputting this. Remember the format specifiers for strings, for string characters: year, amount, and deposit. This is our first heading of the makeshift table. This is our calculation using a for statement. Integer year, we're setting it to 1. We're restricting it to less than 10 years, and we're post incrementing it. The math.power, remember, is in the form of x comma y, and we're setting this 1.0 plus rate, whatever the user enters, to the rate of year. System.out.printf, we're printing out the year and we're restricting it to 4 characters, and then we're printing out this %20.2f. It's going to put a comma separator in the thousands. Then year and amount are the values we're extracting and inputting here. Then we're entering our class. So let's run this again. I know we entered just 1,000, but let's enter a really weird number like 9,846 and 73 cents. And then let's enter a rate of 0.114. It should still work. Yes, the numbers are calculated, and there it is, a much more flexible program. Well, folks, This brings us to the end of this tutorial. If you have questions on anything you've seen, please let me know in the comments. Also, if you have an idea or you want to see a specific program covered in this series. Thanks for watching, and as always, I'll see you next time on an Ecology Designs production. What's going on, everybody? Boris here at the Ecology Design Studio, and today I'm bringing you 20 free software pieces that you don't want to miss. What's going on, everybody? Boris here at the Ecology Design Studio. Today I'm bringing you a quick tutorial on how to best structure your resume.